Cool, so now that we have the height between the ship and the track computed, right, and theoretically that height is going to give us how far we are from the track, we can use this height to compute this attraction and repulsion forces, right? So let's just think about the attraction, right? This thing almost like pulling the gravity down. I think that is almost like that F down, right? But I'm going to just quickly add force dot Vx. I'm just going to add to the final resulting force that we have for the ship. So force Vx, it is, well, it is in the direction of the normal, so section normal, actually minus the normal, so it is pointing down, dot Vx. How much do we have to point down? Well, this is something that we'll have to find, right? So let's say track pull, right? So we're going to have to find a value, track pull, and I'm going to have to declare this constant. We're going to find a value here. So this is the force of attraction, pulling down, and it has three components, y and z, y and z. Let me just go ahead into the globals.h and say that we have define track pull something. We're going to have to find a value, and also define track push. We're going to have another value. Track pull. Let me just say that I want to pull 128. I think I've used this value before and it kind of looked okay. So in ship.c, we start our force that we're going to apply to the ship with 0, and then we start adding, right? The x, y, and z for the force is the flip normal, x, y, and z, so it is in the direction of the flip normal down, times this value right here, which we're going to have to find, right? How strong we want to pull. Let's just see how this looks. Oop, same thing again. It's not section, it is the ship. Section, ship, closest section, and ship, closest section. The closest section of the ship. Right. And now if we run, I expect to see the height is going to be the same, right? Right, so we are pushing down, right? There is a force that is pushing down, but we have to counteract that force now pushing up. So how do we define how much we have to push up? Well, right here, we're going to have to do something very similar. We're going to add to that resulting force. So again, force of the ship dot Vx plus equals, right? So we're always adding to the force. It's going to be in the direction of the normal of that section. So the same thing, ship section normal dot Vx. So now it is in the direction of the normal, pointing up. And I'm going to have to multiply, I think it is called track push, right? We're going to have to find a value. And remember how we also decided that we have to divide by the height, right? Inversely proportional. The bigger the height, so the bigger the projected dot product, the bigger this height distance, the smaller is going to be my force pointing up. And the smaller the height, so the closer we are to the track, the more we have to push up and repel that ship from the track, right? So let's just replicate this for y and z, y and z, y and z. And this one right here has to be really a big number because we have to really counter this attraction force down, right? This big thing that is pulling down. So let's just say that we have 30,000 here. I think that was the value that I used before and it looked okay. Which means that we have no errors, so that's good news, right? One thing done. If I run this thing, I am going to have now a force pulling down, but another force pulling up. You see, kind of okay, right? They are kind of counter each other, and if I accelerate and if I try to go up, there is a force that prevents me from going up, right? And if I try to go down, there's also a force that doesn't let me go down beyond the limits of the track. So I'm always attracting to the track, even here. If I go here, if I shift, it kind of pulls me to the track. And if I try to go up too much, it doesn't let me and just kind of pulls me down. Right? Maybe we can kind of change those values, right? The push up and down constants, more or less, how much we want to attract down. But I like that. Very well. And I know that I kind of already came here and I gave you these values, but again, I just want to respect everyone's time so we don't have to start playing around these values in real time, right? I'm already giving you like this 128 and 30,000, they kind of make sense. So whenever we are applying these forces here, right? So this force, remember that this force is the force that we are using here in our acceleration, right? We are using the force dividing by the mass to find the final acceleration of this frame. And this force right here, it is a combination of, starts with 0, and then we have the pull, attraction force, and then we add with the push, repelling force, and then we add the thrust, and then we get this acceleration, then all these things, right? The thrust, the repel, the push, the pull, all these things, they are being added to our force, right? So our force vector is the resulting force of all these things combined. So there you go. I think this is, look, I'm not going to go too far. Of course, you can really tweak and make things smoother, make things more juicy, right? So you really can tweak these values and really make something more juicy if you want. I am just not going to do that. I'm just going to go with the simplified version. I just want to keep the ship attracted and close to the track, right? So I don't want to let us go too much up or too much down. We might think about this collision on the left and collision on the right as well. Let's see if we can think about that. But for now, I'm just going to leave it as it is. Maybe we can change a little bit of pace and think about something else. Maybe audio, right? Adding a little bit of background music, adding some sound effects. That should kind of be something cool as well. But there are some things that we have to come and revisit, right? Showing objects around the section. So how do we define now what are the objects that we have to render around our section or our track, right? Because we have to decide all those visible objects. I don't think it is a good idea for us to keep relying on that distance check for each one of those scene objects. Maybe we can change that as well. So there are several things that we have to polish here and there, but you see, we are getting there, right? We are getting into a position where we have a moving ship, we have the track, everything is correctly being loaded, the orientation, the rotation matrices, the translation, projection. There is a lot going on, right? For an introduction course on the PlayStation, we are really going above and beyond, and I'm really, really happy that we are able to reach this stage right here and see stuff on the screen, right? That is really, really a great milestone for all of us.